This is a pocket watch. Specifically, it's an American Railroads chronometer from 1870, made of brass, steel, and jeweled bearings. Cost about 2 weeks' wages for the average worker. But here's what's remarkable. Inside this watch is a small piece of metal called an escapement. It's about the size of your fingernail. This tiny piece controls how fast time moves, 1 beat per second, consistently, reliably. Thousands of pocket watches, all slightly different, but all trying to do the same thing, agree on what now means. But here's the problem that destroyed a nation's schedule. No two watches ever told the same time. Even the best American chronometers could drift by 10 seconds per day. The cheaper pocket watches, sometimes a minute or more. Season 1, Episode 1, The Day We Sold the Clock, August 12, 1853. Providence, Rhode Island. Two passenger trains are scheduled to depart within minutes of each other on the same track. Engineer A's watch says 3:15 p.m. He's on schedule. Engineer B's watch says 3:20 p.m. He's also on schedule. They're not lying. They're not careless. They're just using the time that their town provided, and each city had its own official time, set by the local clock tower. The crash happens at what Engineer A's watch reads as 3:22 p.m. By Engineer B's watch, it's 3:27 p.m. 14 people die. The official investigation concludes the accident was caused by a difference in the time kept by the respective station clocks. They didn't blame the engineers. They didn't blame the railroad company. They blamed time itself. This tiny escapement wheel, this is where the problem begins. It's not a flaw in engineering. It's a flaw in human nature. No two watches keep exactly the same time. Each one drifts at its own rate based on temperature, humidity, wear, the craftsman's precision. In 1853, a railroad conductor carrying a chronometer that gained just 2 seconds per day would, over a 200-mile journey from Boston to New York, arrive 5 minutes ahead of his schedule. For 1,000 years, this didn't matter. A horse traveling the same route would take 3 days. A 5-minute difference, invisible. Time was local. Every town set its noon when the sun peaked directly overhead. The farmer didn't care what Paris thought was noon. He cared about his own shadow. By 1800, Europe had hundreds of different official times. Paris was 9 minutes and 21 seconds ahead of London. Every border crossing meant a slight adjustment to your pocket watch. People accepted this. It was just how time worked. But then the railroad changed everything. A steam locomotive can travel 30 miles per hour. That's 100 times faster than a horse. As the train moves west, the local time on the tracks shifts. But the railroad schedule doesn't care about the sun. It only cares about the clock. A train leaving Boston at noon, Boston time, was scheduled to meet the New York Express in Hartford, where the clock ran 6 minutes slower. This meant the conductor constantly compared their fast watch to the station's slow clock. The schedule was meaningless. Every minute of time gained by traveling west was a potential risk of collision or a missed connection. The schedule was no longer a reliable guide. It was a source of massive confusion. This created cascading scheduling catastrophes. Between 1840 and 1880, there were over 8,000 train accidents in the United States. Not from mechanical failure, not from reckless driving. From the simple fact that no one could agree on what time it was. By 1880, American railroads were losing $2 million per year. That's $60 million today. To scheduling chaos, missed connections, and wrecks. Vanderbilt, Gould, Harriman, the railroad magnates realized something radical. The problem wasn't the trains. The problem was time itself. On November 18, 1883, something extraordinary happened. The railroad companies simply decided to change how time worked in America. They didn't ask Congress. They didn't hold a referendum. They issued a decree. Effective immediately, America would no longer have hundreds of local times. America would have four: Eastern Time, Central Time, Mountain Time, Pacific Time. It was a unilateral act of economic power. In major cities, church bells rang twice, once at the old local noon, once at the new standardized noon. Some towns rioted. Religious leaders called it blasphemy. Newspapers declared it a violation of natural law. But the railroads had already decided profit trumps tradition, and it worked. Crashes dropped by 40% within the first year. Delays disappeared. The railroads saved millions. Within a decade, almost every city in America had abandoned local time. Not because it was right, not because it was natural, because it was profitable. But America wasn't enough. For global commerce to work, for ships, telegraphs, and railroads to actually coordinate across continents, the entire world needed to agree on something. Where does time begin? October 1884, the International Meridian Conference. 41 delegates from 25 nations gather in Washington, D.C. Their job: choose the prime meridian. Choose where 0-100 begins. France proposes Paris. They have scientific arguments. French astronomers had revolutionized measurement. The metric system was French. Britain proposes Greenwich, a suburb of London. They have a different argument. By 1884, Britain controlled 72% of the world's oceanic commerce, 90% of global shipping charts, all using Greenwich as reference. The largest navy on earth, the dominant telecommunications network. The British didn't argue their case on merit. They argued it on dominance. Britain's delegate essentially said, "We don't need permission. Every ship on earth already uses our 0 points." The vote 22-1. The French walked out. For the next 27 years, France refused to recognize Greenwich Mean Time. Their maps labeled it Paris Mean Time minus 9 minutes and 21 seconds. This petty protest meant French trains and telegraphs had to maintain two schedules for 3 decades, sacrificing national efficiency just to reject British economic supremacy. Because France understood something crucial. Time wasn't neutral. Time zones weren't about astronomy, they were about power, and they had just lost the auction. Here's the paradox that defines this entire story. We solved the problem of the pocket watch, that tiny escapement wheel's inability to keep perfect time, by creating a solution that has nothing to do with physics. Today, we use atomic clocks accurate to a billionth of a second. We synchronize global networks instantaneously, but the system we use, coordinated universal time, based on the prime meridian at Greenwich, that was chosen not because it was scientifically optimal. It was chosen because Britain had the most cargo ships. Modern traders now pay millions to place servers 3 feet closer to exchanges, because at the speed of light, 3 feet equals nanoseconds, and nanoseconds equal billions in profit. We didn't solve time. We militarized and monetized it. The irony, that tiny escapement wheel that caused the Providence crash, that sparked the railroad revolution, that led to the British Empire dictating time to the world? It was solving a problem that no longer mattered once we decided time was about commerce, not accuracy. When you understand the anatomy of time, when you see how a mechanical problem with pocket watches led to the railroad revolution, which led to one nation selling global standardization to everyone else, you understand something more dangerous. Systems aren't born from consensus. They're born from crisis and seized by power. Next week on the historical anatomy of, we dissect another object you've never questioned, the flag. Why those colors? Why that pattern? Why does your nation's flag look like it does? You think it's tradition, national pride, historic legacy? It's a trade negotiation. And the colors that won, they were chosen by the same people who sold you time. If you want to understand how power disguises itself as nature, hit subscribe. Because every system you live by, time, borders, money, symbols, has an anatomy. And once you see it, you can't unsee it. See you next Sunday.